The agent lifecycle involves sensing the environment, making decisions, performing actions, and observing changes. This cycle repeats, allowing agents to continuously adapt and learn from their surroundings. The first step in the agent lifecycle is understanding the environment, which includes everything around the agent, like traffic roads or classroom settings. This information is crucial for the agent's decision-making process. Perception involves collecting information from the environment using sensors or inputs. Without perception, an agent cannot act intelligently, as it relies on this data to make informed decisions. Decision-making is the brain of the agent, where it chooses actions based on rules, goals, and past experiences. This step is critical for determining the agent's next move in its environment. Once a decision is made, the agent executes the chosen action, affecting the environment. These actions lead to changes, such as a car applying brakes or a robot turning left. After an action, the environment changes, providing new information for the agent to observe. This step is essential for the agent to adapt and refine its future decisions. The agent repeats the cycle of perceiving, deciding, acting, and observing changes. This continuous loop allows the agent to learn and evolve throughout the simulation. The cycle of perceiving, deciding, acting, and observing changes repeats, enabling agents to adapt and refine their behavior. This ongoing process is fundamental to intelligent agent design. In agentic-based modeling, complex behaviors emerge from simple rules followed by agents. This phenomenon, known as emergence, illustrates how local actions can lead to sophisticated system behavior. Imagine a city with blue and red families, randomly placed. Everyone prefers some similar neighbors and not too much crowd. What do you think will happen over time? Each family follows two simple rules: avoid crowd and stay near similar neighbors. Are these rules strong or weak? They seem very simple and weak. In a classroom example, students move if too many stand near them and try to stay near friends. They naturally form groups, even though no one told them to. Simple rules lead to complex results. Initially, random movement occurs, then small clusters form, and finally, large separated groups appear. Surprisingly, segregation happens even though nobody wanted it. Let's quickly summarize. Intelligent agents can learn, adapt, and make decisions. They are different from traditional software. Environments affect how agents behave. Agents follow a cycle: perceive, decide, act. Simple rules can create complex behavior, emergence. Understanding these fundamentals is the first step toward mastering AI and agent-based modeling. If you found this video helpful, please like, share, and subscribe to the Edu AI Verse channel for more educational content.